It's a pleasure to be here. So I want to give a quick overview. So I'm essentially a chemical biologist who has broad interest in discovering new bioactive molecules. And for much of my career, we've been interested in developing molecules that could be useful for treating infectious diseases, where we're looking for molecules that can kill pathogens. But we've been thinking more recently about this idea of trying to move into a new area of discovering molecules that can modify behavior. So switching from sort of infectious diseases to neuroscience. So how do we discover molecules that actually perturb behavior? We have to think in fundamentally new ways, right? We can't do sort of cell-based assays to do that. We need to work within organisms. So we've been taking advantage of zebrafish as a model system for the discovery and characterization of neuroactive compounds. These are very simple animals. They're vertebrates like us. They share about 70% of the genes. They're very cheap to maintain. You can manipulate them genetically, optogenetically. You can image their entire central nervous system. When you actually want to drug these animals, you don't have to inject them with anything. You just add the drug or the small molecule of interest to the water, and it has an effect. And you can literally study thousands of animals in a single experiment with this model. Here's a 96-well plate where there are nearly 1,000 animals in this system. So if you want to measure or monitor the behavior of these animals in this system, you need to have a way of doing it. So we have been using a system that's invented by some of my collaborators and colleagues at UCSF, David Coquel and Matt McCarroll, where you can actually image the behavior of zebrafish in a 96-well plate that have been treated with drugs of interest or with new chemical matter. And you can simply get a readout where you can expose fish over a period of time to different types of stimuli. It's indicated on the y-axis here. On the x-axis, excuse me, on the y, you can actually monitor the changes in motion. And it turns out that neuroactive drugs distinctly modify the motor responses of the animals to the stimuli. And it's very, very stereotyped. So we have been using this platform for the discovery of chemical matter. So to date, we have discovered anesthetics, we've discovered sedatives, we've discovered analgesics, we have compounds that can reverse addiction, and we're also looking at compounds that can be used for opioid and other drug overdoses. So thanks. I'm happy to talk with anyone about this. I'm a natural collaborator, so hopefully there are some opportunities here to discuss.